Dynamic reverse engineering tutorial. Got these binaries here. Same idea. You run them, nothing happens. You get one as a return value, but that isn't very helpful. See, like 1, 2, 3, 4, 5 maybe? Nothing. So yeah, the first thing we can do is strings, because of course. You can see that we got puts and str compare final fight. That's strange. Hi there and password. Let's see what hi there does, right? Nothing. Okay, what about final fight? Okay, we get the win condition. So that's interesting that we were able to use static reverse engineering to figure out what the win condition is, but let's make it make sense for a more difficult binary. Just pretend for a moment that this is something that is way more difficult. So here's our first bit of reverse engineering. Get the disassembly. So you can see main is at 1080, and we do a move here. This puts 1 into EBX, and then we do a compare of 1 to the first argument, which is argc, and then a jump if it's less than. So you can see that, yeah, AA is here, so essentially does nothing if that happens. So let's try to get here, right? Past this jump. So we'll do a run, and then jump star there. You can see it segfaults. See where it segfaults. 8F. Segfaults right at the place. Yeah, so it's trying to do a move here, and all that's, yeah, that's kind of messed up. So let's try and reverse engineer this a little bit more. You can see there's this LEA and then call the puts. That's got to be where the win is, right? There isn't anything else going on in this function. So yeah, this address is interesting to us. And you can see it jumps there right here. So let's just jump there instead, right? So we can do that, even though it's segfaulted. Segfault just means that it's stopped. Unfortunately, segfaulted again. That shouldn't have happened. Oh, my bad. We're using the wrong addresses. I totally forgot about that. Of course. So yeah, when you start a program, it gives the correct addresses here. So yeah, we just have to do that. And then you can do disable 1, disable 2, and oh. Okay. All right, yeah, we want to jump to this other address, right? Mistakes will be made in these tutorials, even though I've done them like 7 times. So there, we got the win condition and we got the segfault. Let's try and get rid of that segfault, right? So we kind of know how this program works now, right? If we take a look at it, it's just doing a push, mov, compare, jump, jump, right? So there's nothing after the push that actually changes the stack. So we should be able to jump right after the push. So let's do that. So if we run, right, we don't have a breakpoint. So break main, run. So now we can step 1 instruction, and that's the endbr64. I don't even know what that does, but it doesn't matter. And then that's after the push, and so now we can do the jump. to here. And no segfault. Great. So the next question is, what else is there that's like jump? Well, if we run again, did you know that you could call system from here? I bet you didn't. So there we go, and we see that GDB won't call it without return type. So we can just use int here because that's the return type of system. But we could also do it if it wasn't the return type of system. We're just casting. You can see that now we've called a function from GDB, and it doesn't cause any harm to the program. We can just do continue, and everything runs just like normal. Like nothing ever happened. And that is how C works. I mean, you can call any function you want at any time and, not cause any problems. It even figures out how to do, this part for us, which is kind of cool. And that will help if you have, like, say, a network program that shares its secrets, but it's really hard to get to the point where it shares its secrets. Well, you just jump to where you need to jump to, and you set up the stack in the way you need to, and then you call the function just like this. What if you don't have, if you don't have a name for it, right? Well, you can do, so let's run again. Call star int, and then have our thing there. And you can see we got our win condition, and then it segfaulted because, of course, our stack wasn't prepared. But if our stack was prepared, we'd be in good shape. That is how it works. And that's all I got for you. Next time, we'll be working on a much harder piece of software. I'll find one, and we'll reverse engineer it. And until then, good luck on all your projects, GDB or otherwise, and I'll catch you next time.